but I'm a big boy and a professional, and so I can manage that probably. All right. So last time we finished off, we gave kind of an overview of the two examples that we're going to run through with this mixed factors ANOVA. Okay. Remember, with the mixed factors ANOVA, what we're taking that one-way repeated measures ANOVA, and we're layering in a between subjects factor, at least one. Okay. We're going to take the same data set that we've been using for the one-way examples, and we're going to layer in a between subjects factor in this. Okay, and then go through and kind of walk through and see what's happening with some of this stuff. So for the first question here that we're going to work on, remember we've got depression scores that we've measured from inpatient clients over the course of a 6-week hospitalization. We have scores at intake, 2 weeks, 4 weeks, and 6 weeks. And then what we're going to do now is we're going to add in 3 different treatment programs. We're going to say these folks have been set to receive different types of interventions within this program. And the question is one, do we see changes in the means of depression scores across our repeated assessments? That's our main effect of our repeated assessment. We're going to ask, do we see differences in depression scores across treatment programs collapsing across repeated measures? Is this an interesting question? No, not really, right? Because the average score across intervention doesn't really mean anything, but we're going to get that still, okay? This is an important piece when you're looking at output, right? You're going to get things, particularly for packages like SPSS, that's just going to give you everything. You're going to want to know what those things are, whether or not they're relevant or not, and sort of make decisions from there, okay? But then what we're going to do here is we're going to go through, and we're also going to take a look, and we're going to ask whether or not the pattern of depression scores across repeated assessments differ or vary based on treatment assignment. What are we looking at here? Basha? Their interaction, absolutely. Do the differences we're seeing across repeated assessments, this within subject effect, does it change? Does the pattern change in some way based on what treatment you're assigned to? So we've got a between subject factor that's moderating or changing the within subject factor, okay? So let's go through and open up your, not the belief rating, the ordered means here, okay? We're not going to go through and screen these data. These data are pretty much fine. We'll go through and screen the between subjects stuff. But if we go through, remember, and we sort all that, that's all looking good, okay? And so then we have program, and then we have gender here. What we're going to do is we're going to sort by program, because this is an irrelevant variable for us in this example. And we're going to say that we've got 23 cases with missing values. Can we use those cases? No, they don't have between subject stuff in them. So I'm going to go through and nuke those. All right. So left with my analyses here. So what I'm going to do is I got a within subject factor and a between subject factor. Getting this pretty straightforward. We're going to do the same thing as we did before. We're going to go to analyze, general linear model, down to repeated measures, okay? And factor, we're going to call this, maybe we'll call it time. How many levels do I have to my factor?
Subject, right?
Yeah.
So there's 4.
4. I've got 4 repeated assessments. Going to hit add, then you hit define. Okay. I've got BDI 1, 2, 3, 4, 1 intake 2, 4, 6. Going to drop that in my time. And then what I'm going to do is I'm going to go through and I'm going to select program, and I'm going to drop it in my between subjects factor. Okay. That's saying that I'm going to have specify that, yes, I want to see whether or not I have differences in these means over time. But also what I'm going to want to do is I'm going to want to look at the extent to which those change depending on what program I'm looking at here. Okay. So what we're going to do is we're going to go up to, if you look at your model, this is just different ways you can specify your model, change things around, change your sum of squares. You're generally not going to want to fool around with this, so we'll just hit cancel. Contrasts, this is where we're getting our polynomial contrasts and things along these lines. We've already seen that already. We're going to get some stuff, so we don't have to fool around with anything here. Now, plots. What I'm going to do here is you got to think a little bit about how we want our plots. What factor do we want on the horizontal axis? Yeah, Elizabeth? Yeah, my repeated measure of time, right? So that's going to be on my horizontal axis. And what might be useful to look at in terms of separate lines? Amanda? Yeah, program. Okay. So what this is going to do, and there are different ways to set this up. Hit add. There are different ways to set this up. You can look at separate plots and things along those lines, but this is kind of the standard one that will give you your factorial design here. All right. Now, before we had hit error bars, I'm actually going to skip it on this because I've done it before. And what it does is just puts a bunch of error bars. It kind of messes up the thing so you can't really see it. You can go through, it's always good to click it to see what happens. But in this case, it's going to kind of fool around with being able to interpret the plot. So we'll just skip that. Okay. Post hocs. Now we can get post hocs. Here, you can request, I want post hocs for programs. What this is going to do is it's going to compare across these groups, but this is not a useful thing unless you know specifically what you want to do. We're going to go through and take a more systematic approach to this. Okay, so we're going to hold off on this for right now. Okay. Marginal means, this is fine. So we can go through and get means for this if we want to just go through. We'll get descriptives at the front end, but it's you kind of have to go through and sort things out and trying to figure out what mean goes to what. Requesting the marginal means, we'll go through and kind of order those up so it's easier to see. Now, I would say these marginal means are going to be adjusted means, so that in these more complex models, they're not going to be exactly the observed means that you see across the different groups. I tend to plot observed means just because that's what we're seeing as opposed to adjusted means. They can kind of start to be off, but sometimes it's nice to go through, request these, just so when you see on the output, you can go down through and say, okay, here's the difference between this and this, this and this, this and this, and there should be pretty close to your observed means. So we'll request these. Not going to save anything, but then on options, I'm going to ask for descriptive statistics, effect sizes, and then I'm going to request homogeneity variance test. Remember, we got an error message when we tried this with before. Why did we get an error message when we were doing this with just the one-way ANOVA stuff or one-way repeated measures?
Between subject factors.
Yeah, we didn't have between subject factors, so there was nothing for it to test. SPSS won't test for us homogeneity of variance within subject factor, only between. So, but now that we do have between subject factor, we can go through and we can hit that. Okay. So I'm going to go through and I'm going to hit paste. See our program here. And what I'm going to do is I'm going to go through and I'm going to run this. But then what I'm going to do to help out is I'm just going to switch over to our output here because it'll be a little bit easier to see on the screen. Okay. But what you're seeing on your own stuff should map up exactly onto what we're seeing here. Okay. So going down through, taking a look here, you're going to see your repeated measure. Always important to take a look at that. Make sure that that's in the order that you've sort of put it in. We've got 1 is BDI 1, 2, 3, 4. That looks good. Our between subjects factors, looking at those, want to eyeball those numbers to make sure those map onto what we think we're doing. And then we've got our descriptive statistics, right? What SPSS does is it says intake, program 1, 2, 3, and then what's this total here? What do you think? What is it, Allie? So we got for program 1, we've got or so for at intake, we've got mean and standard deviation for program 1, program 2, program 3, and then yep, collapsing across groups, right? And if we go through and we take a look at the value there, if I want to just say across collapsing across group, what's the mean value at it, or the mean value at intake? It's right down here on this total. Okay. Same thing for BDI 2, same thing for BDI 3 or BDI 2, BDI 4 weeks, BDI 6 weeks. Okay. So here you have all of your observed means. You just want to make sure that you're navigating this and know what means corresponds to what. Okay. Yeah.
Just to clarify for the class across group, if he intake is not program or something.
Yep. Just at intake. So if we collapse across intake, if you went through and just ran descriptives on BDI at intake, this is the mean standard deviation you would get. Okay. So Amanda, if I wanted to look at specifically the trajectory of scores for program 2 across my repeated assessments, what would my first mean be? 28.69, yep. And then 17, 13, 9.39, yep. So just want to make sure that you orient yourself to that table and understand where these means are coming from, what they correspond to. Okay. Actually, I'm going to switch back over here to our output. So we've got this, and this is our box test of covariance matrices. I think I ignored that in the output. This is just looking at that sphericity, some of that sphericity stuff. Ignore this. You don't need to worry about it. It's not a great test. So we'll just ignore that. Again, here's our multivariate tests. Our multivariate tests are a different way of looking at this, kind of taking like a MANOVA multivariate type of approach, traditional multivariate type of approach to looking at things. Are we going to pay attention to this? Nope, we're going to ignore this, because what we're going to do is we're going to go down and take a look at our within subjects effects. Here's our test of sphericity. Do we need to concern ourselves with this a whole lot? Nope, because we always just assume that we've violated our sphericity assumption and are going to proceed directly to our greenhouse geyser correction in our within subjects effects. Okay, and so now I do get into my within subjects effects. So I'll turn this back over here. And Riley, what are we seeing for my within subject? What is this session here? That's still kind of hard to see. So what is this first in my test of within subjects effects? What is this first session effect telling me?
I'm so honest, I can't see it.
Okay. Does someone, Basha, you look like you want to tell me. What is it? Yes, perfect. This is just my main effect of my repeated assessment. This is saying, and do we have evidence for an effect here? Yeah, and it's massive, right? This is saying collapsing across groups, right? Ignoring treatment group. Do we have evidence of differences across my repeated differences in means across my repeated assessment? My F is close to 440. Yeah, that's huge. My partial eta squared is 0.55, right? It's massive. Okay. So we have very, very clear evidence that collapsing, ignoring treatment group we're seeing changes in our depression scores across our repeated assessment, okay? Now, what about this? If we go down, we see this session by program. What's that giving me? Elizabeth? Yes, it's looking at the differences in time frame across those three programs. And if we look at my greenhouse geyser, P, do we have evidence for an interaction here? Okay. What does this tell me? And folks, you have this sort of in those things that I sent. There's a PDF that has that. If so, yeah, don't give yourself eye strain. How do I interpret that interaction effect? Amanda, you want to answer? Yes, yes. So, and anytime we see an interaction, we're saying that something is dependent on something else. In this case, what is this telling us? Beautiful. Changes in my depression scores over repeated assessments is dependent on what program I'm looking at. Telling me that if you ask me, hey, how do depression scores change over the course of repeated assessments for people involved in this program? You say, I don't know. You got to tell me which program they're in, because the program changes the way we're seeing, changes the pattern of means that we're seeing in these data. Okay. And this, with this type of design, this is often the types of things that we're looking for. Okay. Now, we go down here to our within subjects contrasts. Ignore these. For the one ways, they were fine. For the mixed factors, ignore them. We got better ways of going through and probing things. Okay. And then what we're going to do, go back to our output here. Okay. We've got our Levine's test for equality of error variances. What is this giving us? Yeah, you're exactly right. Homogeneity of variance. And Matt, we've got a number of different lines. Any thoughts on what might be, how this might be getting partitioned out here?
It's like it's separating it by to the repeated measure, so by time.
Yeah. So for each one of our repeated measures, we're saying, do we have evidence of differences across group at intake, at 2 weeks, at 4 weeks, at 6 weeks? All right. So Matt, do we have evidence for differences across groups at intake? No. Everybody's pretty much the same at intake in terms of variability in BDI scores in the terms of their across our groups. Is this a good thing? Would we expect this? I know you're not a clinical person, but does this make sense from a basic design standpoint? Yeah. If we've gone through and randomized people to different groups, we would hope that when we start, everybody's kind of doing the same thing. Okay. What about at 2 weeks? Are we seeing evidence for differences in variability across groups?
Not quite yet.
Nope. What about 4 weeks?
That looks like it's started to.
Starting to, and what about 6 weeks?
Not definitely.
Okay. So what we're seeing, and this is not uncommon for like this type of data, to see everybody kind of starts the same, but as soon as we start a manipulation or something like that, people start to drift apart, right? We get differences across different groups as we go across in time. So this is something to be thinking about. Here, remember that we have, for these analyses, we have an assumption of homogeneity of variance, both within and across groups. Here we're seeing by the time we get to our second and third, or excuse me, our third and fourth time point, we're seeing problems with or potential violations of homogeneity of variance. What's the one thing I might sort of mitigate or sort of pump the brakes on before I get too excited about this? Yeah. So Natalie, if I'm looking at this, I have evidence for a violation in that I have p-values less than 0.05. What might make me want to sort of not get not lose my head too much. Linda?
I think that since we have your sample size as an each group, it can kind of do both.
Yeah. We've got a lot of people in this group. And remember that these are tests like any other tests. As soon as you get lots and lots and lots of people, it's going to start to pick up on pretty fine grained differences, right? So is this something to be of note of and think about? Yeah, but if we're looking at sort of differences across different ways of looking at homogeneity of variance here, some of them are kind of right around that 0.05. Like it's not, I'm not have like sort of huge flashing lights. When we get down here, it looks like maybe, a little bit more, but remembering that we've got a lot of people in each one of these groups, right? And so taking that into consideration. Still with this, we probably wouldn't want to just go through and start pulling error terms from any of these tables for follow-up tests or things along those lines. But it's definitely something that we would take sort of with a grain of salt here, okay? So last thing we see down here on our table is going to be this test between subjects effects. What's this telling us? What do you think, Brittany?
I had a feeling you're gonna call on me. I just felt it in my bones.
See there, you
If I'm-
clairvoyant. What's up?
If I'm understanding correctly, for the tests between subjects effects, that's like your like your measurement between literally like your subjects, right? So what this is telling us is like for program, it's not necessarily, there's not necessarily a big difference between your subjects.
Okay, yeah.
Okay.
Yep.
Somewhat.
Nope, you're on the right track. And what do you mean, what do you mean by subjects?
Oh, like your individuals, your participants.
Okay.
Mhm.
Ish, kind of. Now we've gone through, remember that's the interpretation we made with the one way when we didn't have a between subject factor. Do we have a between subjects factor here?
I don't think so. Or like between, so when you say between subjects factor, you mean like on the measure?
Yep.
Oh, yes, there is.
Yes.
Okay.
We got an effective program, right?
Yep, that's okay.
And so what are we seeing then in this test? So before, when we didn't have a between subject factor, just asking are people different? Sure, they are.
Mhm.
Now we've actually have 3 different programs.
Oh, so there's not a significant, I'm not saying it right. There isn't like a detectable difference between people on the program.
Okay, across programs. And what's our outcome here?
The- I don't know.
Someone help? Can
Yeah.
someone help her out? No, you're doing a great job. Yeah, Katie?
There's not a difference. For me, it's looking at like the differences or people in different groups.
Yep. So we're looking at differences across groups with BDI scores, but which BDI scores? What's that? Did you say 6-week?
Yeah.
Okay. Remember that remember for our we've got a main effective within, we got a main effective between. Main effective within is collapsing across groups. Do we see differences in our repeated measure? Our between is saying what? Katie?
Is it baseline to 6 weeks?
Baseline to 6. What do you mean baseline to 6 weeks?
Like where, like a baseline score, so like. Wait, maybe not. Maybe, I was thinking maybe it's overall.
Okay. Overall, in terms of average across the whole assessment, right? If we scroll back up to our means, remember I was talking about wanting to know what your means mean? What means are being assessed in this between subjects effect here? Yeah, what in that between subjects effect or between subjects effect table that we saw down there, which of these means is being compared? What do you think, Robert? Yeah. These totals, right? Is or nope, I'm not seeing that. Not in here. Sorry about that. That's for across the repeated measure. If we scroll down to our marginal means, okay? This is the total mean for program 1 versus program 2 versus program 3. So collapsing across all our repeated assessments, do we see differences collapsing across repeated assessments across time 1, time 2, and time 3? Now, did we say that was an interesting effect in these particular data? Nope, it's not, right? Because I don't care what the average of group 1 across 1, 2, 3, and 4 time points is. That's not a meaningful thing that makes any sense to me, right? But you can think about this tested between subjects effects, building off what you were talking about, Brittany. Basically, it's a one-way ANOVA, right? If we just take the average score for each person across repeated measures, and then we take the average of that for everybody in the group, it's just, is the average BDI score across repeated measures different across these 3 programs? Remember when we went through and talked about pulling apart this this repeated measures ANOVA, right? We talked about sum of squares total, got between, within, and then here in a 2x2 design, we've got group, and then we've got between error. Here, we've got our repeated measure. Here, we've got our repeated measure times group. And here, we've got our repeated measure error. Okay. Thinking about this and our components down here that we separate everything down into, okay? Where in my output am I getting that between subjects of my sum of squares? And this is all sum of squares, sum of squares, sum of squares. Okay. Where am I getting this one? My sum of squares group. Where am I finding that on in this output? Matt, you want to help us out?
So it is in the tested between subject effects table, type 3 sum of squares column, right next to program,
Yep. And where's your error sum of squares?
right below that.
Right below it. Okay. This is, if we're taking your total all variability, that we're sectioning this off, right? This is all your between subject stuff. This is all the stuff that's due to individual differences. This is all that individual difference stuff that we're just pulling out of that error term and setting over the side. And what does that do to my error term for my repeated measure stuff? Shrinks it way down, makes it much more powerful, right? What about, Basha, where am I going to find my sum of squares terms for everything over on the right there? Yep, it's moving up. Okay. So where's the sum of square of my repeated measure?
It would be the session.
Yep. Right there. Okay. What about my interaction?
That would be the greenhouse geyser.
Yep. And my air?
Yeah, under the air.
Okay. So thinking about where we can go through and how this is all getting partitioned out starts to become very, very important in how we're thinking about calculating effect sizes, how we're going to go through and probe things, right? Knowing not that this is just a giant table full of numbers, understanding where these are coming from and what these represent starts to become important for this and then moving forward with other stuff. Okay. All right. Questions on this? Okay. So in terms of our omnibus tests, what we've got, if we want to ask for just our omnibus, oh, Katie, yeah.
So what, like, or what design?
I'm sorry, what's that?
What model or design?
Here we're working with a 2 by, what is this? This is a 3 by 4 mixed factors ANOVA. So we've got 3 levels of my between, 4 levels for my within. Okay. Now, as we go into your assignment, people who have looked at the assignment, what model are we working with in the assignment?
Which problem?
They're actually both the same, aren't they?
What are the levels changes for third one?
Okay, so what is the first one then?
2 by 2 by 2.
Okay, in the assignment, we've got a 2 by 2 by 2, right? So what does that 2 by 2 by 2 mean in terms of design? What have we added to that one? Yeah.
No, you before.
Like, no, you go.
Is it the two between and then one within?
Yeah, we've got 2 between factors and 1 within factor. And so what happens when we get to our output, right? Now, all of a sudden, we're going to have a repeated measure. We're going to have an interaction of our repeated measure and our first factor between. We're going to have a repeated measure in our second factor. And then what happens when we get down to that between subjects factor table? What are we going to get there?
Interaction between both between subject factors
Yeah.
and the within subject factors.
Yeah. What, not the within, because the within goes up. But if we go down through, instead of having this piece that gets pulled out, having that be a one-way ANOVA, factorial ANOVA now, right? So collapsing across all scores across our repeated measure, do we see differences across levels of factor 1, ignoring factor 2? Do we see differences in levels of factor 3, ignoring 2? And then do we see an interaction of those? Okay. So it just all builds on one another. You just have to sort of go through and sort of think carefully, take a step back and say, okay, what am I looking at? What does this mean? And as soon as you have a good sort of solid understanding of, anytime you see a between by within interaction, it just means that the pattern of means across this repeated assessment differs across these two groups, right? Or if you see a between subject factor, you're saying, okay, there's some sort of differences collapsing across my repeated measure, right? This isn't any different than what we were doing before with our early on with our factorial ANOVAs. There we were also, when it was just all between, we're still going saying, this is differences in factor A collapsing across factor B. This is difference in factor B collapsing across factor A. These are sort of the differences in the cell means across, right? It's all the same stuff. We're just adding in different factors. So the trick is keeping track of what's what and where things are going and what things mean. Cool. So if we go to our omnibus effect, right? So we go through, and with these ANOVA designs, we start with our omnibus effect. And we see here that we've got evaluation of a 3 by 4 mixed factor ANOVA with repeated measures on the assessment on the final factor, offered strong support for a group by session interaction. Here we got a P equals 0.004, S is 8, Bayes factor 16.6. And so what we can say here is results suggest that reductions in depression over the course of intervention differ by treatment group. Okay, that's very much, that's actually me cheating a little bit. Where did I cheat in this interpretation here?
I'm taking error messages on my computer, so I was not paying attention.
Yeah.
But you repeat the question.
Yeah, so I say, so the last line here for this interpretation say, results suggest that reductions in depression over time or over the course of results suggest that reductions in depression over the course of intervention differ by treatment. Where did I cheat a little bit on this? And so pull outside information. Yeah.
You're thinking exactly in that percent number reductions or?
Elizabeth, if I just look at that within subjects effect, do I know that those are reductions?
Yes, no.
No, I don't. Why not, Josiah? You're shaking your head.
Because we just know there's differences.
Yeah, we just know that there are differences. Right now, if I go through and if we go through and we take a look at our output here, we very clearly see that there are different, there are reductions, right? So I can just eyeball this and say, yeah, the pattern that within subject effects is consistent with reductions over time across all of these groups. They're all associated with reductions, right? So I don't need a damn statistical test. I can use my eyes and say there are reductions there, right? But I don't know that just based on the omnibus test. Based on the omnibus test, I can say that changes in depression across repeated assessments are dependent on group, but I don't know what the direction of those patterns is. Now with ordered stuff, it's often nice and sort of easy to define. When we roll over into the in the unordered stuff, that's where it starts to get a little bit messy. Okay. All right. Questions about our overall interpretation of what we have going on here from an omnibus perspective. Okay, let's roll into let's pop open our unordered means stuff and pull up the unordered means screening, because we're going to do a little bit of screening with this to start off. Okay, so here what we've got in our screening is we've got again these profiles that we've already established. We've put people into different profiles. We've identified people as negative, who hold negative beliefs about trauma. These are people who think that people who've experienced trauma are scary and broken and not good at much, and you got to keep an eye on them. Okay, we've got a benevolent group that is not completely non-problematic, but thinks the people are fine, they're doing well. You know, people who experience trauma are people just like anybody else. And then we have this interpersonal group say, yeah, people with trauma are fine. I just would be a little bit hesitant to sort of maybe date someone who had experienced trauma, or boy, I don't know that, you know, maybe they're sort of quite as reliable in terms of interpersonal stuff. They probably got some things going on. Overall, good people, but maybe some social stuff. Okay. So we've got 3 different groups that we've classified people in based on responses to a survey. And then what we've done is we've asked those people to respond to hypothetical vignettes about people who have been exposed to different types of trauma. And what we're interested in, so they go through, read these vignettes and say, how willing would I be to maintain friendship with this person? Our questions here with our, what do we got? We got a 3x4 design. Question is, does willingness to befriend vary within people across different traumatic events? So what we're saying is collapsing across group, ignoring profile. Do we see differences in the pattern of how people, the friendship ratings, people respond to these individual vignettes? Okay. And Robert, what effect is this that we're talking about here? That first one. Well, and see, this is where it gets tricky, right? I'm saying, do people, does willingness to befriend vary within person across different traumatic events? What's my repeated measure here?
Oh,
Yeah, it's the vignette, right? Their response across this. So this is my repeated, or this is my main effect of, what's that?
within.
Yep, within. This is the main effect of my repeated measure right here, right? Collapsing, ignoring people's beliefs. Do we see that people respond to different vignettes differently across repeated assessments? Okay. Then we've got, does overall willingness to befriend differ based on belief profiles? Okay. Allie, what's this effect here? What's that? One more time. Out loud, I can hear.
Would that then be between?
Yeah, this is my between. Saying collapsing across vignette, ignoring vignette, just looking at overall friendship rating. Do we see differences across profiles? Okay, essentially, this is just our us sucking out one-way ANOVA and pulling those individual differences out. Okay, and then we've got our last question here. Does belief profile impact the pattern of friendship ratings across traumatic events? What are we capturing here? Elizabeth? The interaction. Yeah, exactly. And well, yeah. And so basically, if we find this interaction, it's suggesting that people's pattern of response to these different vignettes is dependent on what? Their belief profile, right? Hey, how do people respond to these different vignettes about people who've been exposed to trauma? I don't know. What types of beliefs do they hold? if you tell me that, I can get more specific in terms of the pattern of beliefs. Okay. Questions about the setup for this, and I can't emphasize this enough, how important it is before you dive into these analyses to have a very, very clear understanding of what your repeated measure is, what your between subjects factors are, and kind of the whole overall design. Because these are really, really, really it's easy to get turned around in this and sort of thinking about collapsing across what, collapsing across where. So really having something down and like, I'll do this, I'll just sketch out on a sheet of paper. I'm like, okay, so I'm doing this across multiple times, and this is this, and this is that, and this is what this means, so that I have a good understanding of what's happening before I jump right in. Because otherwise, then you're just going to see a damn numbers, and it's hard to keep straight what's what and what's important and what means what. Okay. So if we go through and open up our, not our order means, our belief ratings. Okay. So here, we're going to look at, we got car accidents, combat trauma, sexual assault, and disaster. Okay, looks like I got full information there. And then class, here's my between subjects variable. Looks like I have some missing values here. So what we're going to start doing is working through screening for this. Okay, good news is the screening that you're going to do is the same screening that you ran for ANOVA stuff in between subjects, the stuff that you've done last year or last semester, the stuff that you're an expert on. You're just doing those separately for each repeated assessment. Okay, and that's all it is. Like, well, that's not all there is. There's a couple other things that sort of go into it, but for the most part, when we're looking at distributions, plausibility, all that stuff, the only thing we're doing is just splitting our file into different sort of sections and going through and taking a look at stuff here. Okay. So here, what I would do is I would first go through, if I'm screening this and I say, okay, I've got 8 participants that I don't have a class rating for. I don't know why. They're just not there. Okay. So something that I would want to go down through and take a note of, here you've only got 8 people, so I would go through and just write down like these are the 8 cases where we didn't have profile data for, and just make a note of that. Okay. So I'm going to go through, clear that, right? And then what we're going to do is we're just going to start working through. Again, what we need to do is we need to look at distributions across these 3 different populations. So we've got a negative group, we've got a benevolent group, and we've got an interpersonal group. Each one of scores with each one of these groups represents a distinct population, right? So we want to go through and take a look at the distribution of ratings within each one of these. Okay. So what we're going to do then is we're going to go to, I'm going to go to data as split file. I'm going to want to ask to organize groups by class, or compare groups. We'll do compare groups. Compare groups by class. Okay. I'm going to hit paste. This is not shocking or interesting. You've done this across the board with all of your other screenings with your ANOVA stuff, your t-tests, and all of that. Okay. And so then now what we're going to do, we're going to go analyze descriptives and go to descriptives. And here we're going to choose our car accident, our combat, our assault, and our disaster. Okay. We're going to ask for skew and kurtosis. We're going to ask to save standardized values. And I'm going to hit paste. Okay. All right. And then if I go through and I run this whole thing, all right, I'm going to switch over to my my PDF just so we can see it bigger on there. So basically what I just did in SPSS, we're going through, and first thing it's going to do is it's going to give us a demo table here. Okay. Emily, what are we looking at in this demo table? Okay, cool. So looking at, first just looking at at our sample size. Anything that you're noticing here in terms of sample size? They're pretty uneven. They're pretty uneven. We've got over twice as many people in the benevolent group as our smallest group, which is our negative group, right? Now, in the grand scheme of things, a factor of 2 isn't that big in terms of the types of things. So it's definitely noticeable. We've got an unbalanced design. Are you worried about this sample of 44? Not really. Yeah, yeah. When we get into that, we're gonna see some stuff. But just in terms of sheer magnitude, am I worried about a sample of a cell of 44? Probably not, right? Is it as good as 94? I don't know. Probably not, right? But it's still big enough so I'm not too concerned about like, oh, am I going to get weird stuff going on? Okay, so I'm noticing that I have an unbalanced design, but it's not a ton, but it's still sort of a decent amount, right? What about, Josiah, what about my min and my max? Okay, so these are 0 to 8 ratings on how likely would I be to maintain friendship with somebody. What are you seeing in this pattern of figures here?
On the high side, they're all plausible.
Yeah, everything's plausible, but things are trending up, right? And we talked about this before. The aspect of the design, we're asking people in a confidential, like no cost to you, would you be willing to maintain friendship with somebody who had something terrible happen to them? And probably most people are going to say yes, and that's what we see, but not all people. Okay, and then transitioning that over to, if we're looking at our skew and kurtosis, Amanda, what are we seeing here? Yeah, we've got a lot of really big negative skew values here, right? Skew of almost -4. Yikes, right? Kurtosis of 17. Yowza. Are these data problematic? Why not? Okay, yeah. So we've got a small scale. So in terms of in terms of what is that going to be most important for, Emily? Yeah. Yeah. So the skew makes sense given what we're seeing, right? Okay, I understand why I'm getting these data. That's good. Doesn't necessarily make it not a problem. It's good to know why, but it can still, even if I know why, it can still be a problem. You're saying that's probably not going to be a big issue because of the range of the scale. What is that range of scale probably going to influence most? Yeah, Josiah. What's that? Well, it's gonna, because we kind of only got so many things, so it can't really sort of do the full thing. How extreme can my extreme scores be? Not very big. Like at highest they can be 8. At the bottom we can get, 0, right? I'm not looking at something like income, housing prices, or something like that, where I accidentally captured LeBron James in here, who's going to take that score way, way out, right? So, yeah, the type of the scale is so helping in terms of extreme values. what else has given us a little bit of latitude in terms of seeing something that's, in terms of our assumptions and seeing that the data are very, very much not normal? Do we have assumptions in group-based analyses? Or do we have specific assumptions about the observed data?
Are we looking at the distribution of, that's not the right word for it.
Distribution of the,
All the mean pairs. I don't remember what it's called.
nope, not sphericity yet. Distribution of the, what means? Sample means. Distribution of the sample means, right? Distribution of the sample means is the distribution of the means of all possible samples of size X that could be drawn from a population. And Josiah, when do we know that the distribution of sample means is going to start to become normal very quickly? If you have reasonably sized samples, yep. And what's the other condition? Elizabeth, you want to help out?
Like the underlying theories.
Yeah, if whatever I'm measuring has a normal distribution, okay? Now, thinking about, this is a hypothetical situation. No one's ever done this outside of the data that I've collected, right? So these people are essentially the population of everybody I've collected. But hypothetically, if I were to separate the entire universe into these three profiles and then ask them to rate vignettes, am I likely to get normal data out of that? Probably not, right? Because people are still going to, in general, say, yeah, no, I'd be friends with that person and not be a jerk, right? So when I'm thinking about the distribution of sample means, is what I'm sampling a normal thing? No, right? Katie, if you're doing substance use, are the things that you're sampling often normally distributed? No, right? For all sorts of different types of things, the things that we're sampling is not normal. But as long as we've got a reasonably sized sample, the distribution of sample means will become normal as long as we've got enough folks in there. Now, 30 is like is ish, right? But based on the cells that we have here, should we be at least take it in as a possibility that the sampling distribution of these data will be normal-ish? Probably, right? So we've got a little bit of a buffer there, okay? But the distribution that we're seeing is incredibly notable, right? And if we go up to go back to our data, and I'm going to go through and sort by my subject number, and I'm going to go through and go back to descriptives and go to explore. And for my dependent list, I'm going to have accidents, combat, assault, disaster. I'm going to have class as my between factor, and I'm going to put subject down in my label case by. I'm going to go to plots. I want my histogram, continue. Then you go through and paste that. Okay. Why did I sort that data first? Yes. Yeah, turn off my split file. Otherwise, I'm going to get all sorts of errors and things like that, right? But if I run this, what I'm going to get is a nice breakdown of my distributions, okay? Are these, Riley, anywhere close to normal? No, these are pretty ugly, right? This is, look at that box plot. What does it mean in the box plot if, what does this mean in terms of box plot right here? How do I interpret this? Yeah, Emily?
If almost everyone responded with E.
Yeah. My first quartile, my third quartile, my median are all 8, right? If I look at my middle score, if I take the low 25% of my score, the high 25% of my score, it's all the same. It's all 8, right? So anybody who didn't score an 8 is by definition more than 1.5 times, more than 3 times beyond the interquartile range, because the interquartile range is 0, right? So what we're seeing here, and sort of pulling back through, a lot of you did a really nice job with this in terms of when we're thinking about what we're measuring. Now we're treating these in this analysis as if these ratings were continuous. Are these continuous ratings? What do you think, Rachel? What's that? Are they continuous? Yeah. What's that?
I feel like I'm overthinking this.
No, they're not continuous. Why not? Been a long time since you've refreshed this. Anybody?
The difference between 0 and 1 is not like.
Yeah. No, keep going.
Like 0 and 1 doesn't mean it.
Yeah. There's no set standard between these. One, someone can't take any value between 0 and 8 because they have to take 1, 2, 3, 4, 5, 6, 7, or 8, right? The difference between 1 and 2 and 2 and 3 is not, there's nothing that says that's the same amount, right? It's all kind of arbitrary. There's no true 0 point, that would be a ratio scale. But yeah, this is at best ordered categorical data. Now we've got 9 different values, so we're going to treat it as continuous, and we could probably be okay-ish with that. But we're seeing very clearly ordered categorical data, some ordinal stuff here, right? So going through and taking a look at these for each one of our, so this is just for organization. We've got our accident ratings for negative, benevolent, and interpersonal, and box plots. We got histograms for combat, negative, benevolent, interpersonal, for assault, negative, benevolent, interpersonal, for disaster, negative, benevolent, interpersonal. Okay. So now we've got kind of a situation here. How many individual kind of plots distributions do we have here? Yeah.
12 histograms, right?
Yep, I got 12 of them. This is going to be a lot to capture in your screening if we had to sort of move through every single one of these. And Matt, is there something that's decidedly different going on across these different distributions?
Really?
Not really. They're all kind of going the same direction. Okay. So when we get into the write-up with this, you'll see that for this one, because it's such a big design, there's so much going on that I've gone through and down through and kind of condensed stuff. And so there are some benefits to that because you don't have to, I don't want you writing your name on the board just to write your name on the board just to do it, right? You can go through and look at these and say, hey, these are all kind of doing the same thing. They all kind of have the same problematic stuff going on. Now, I will say, watch out. Now, the stuff that you're doing for actual problem set, that may not be the case. So just be careful in terms of thinking carefully about how you're combining this, how you're sort of processing this stuff out, okay? So we've got clear problems with our distributions. At least in terms of they don't look super normal, right? But now what I'm going to do is I'm going to go through and I'm going to go back and turn my split file back on. And I'm going to take my descriptive statistics. I'm going to put a Z in front of each one of these. What am I doing here? What do you think, Basha? Look at my Z scores, right? And I don't need skew kurtosis on my Z scores. Okay, I'm going to go through, run this, and get my table here. Okay. Erica, what am I seeing in terms of z-scores in this output? If I didn't know anything about this design and I just looked at this table of z-scores, would I be concerned? Probably, right? Because if I'm looking at this, I've got something that's close to 6 standard deviations below the mean, right? The low end of this is all, if we're using 329 as sort of a rough indicator, like something that's a z-score that's associated with p equals 0.001 is kind of just a rough general, like, are we seeing something that seems to be pretty extreme? Here, yeah, they're all over the place, okay? But Josiah, what's putting this into context for me?
Everyone's picking eights.
Yeah. If everybody's eights and then I have a couple of people who put down something lower, it's going to come up, right? And we're going to see this type of thing, right? And then Emily, what else did you say about the scaling that might help me be a little less overall concerned about the possibility of really problematic extreme values? Yeah. So is this problematic and something to note? Absolutely, right? But the question is, with my extreme values, do I have something that's going to artificially drag my mean around? Okay. Now with this, what we're going to have is, as people score lower, it is going to pull down the group mean. But is that kind of what we're expecting to see in this? Kind of, right? The more people we have sort of scoring who's not 8, the higher proportion of people who aren't all the way in on providing friendship, which is kind of the effect that we're kind of looking for or would expect, right? Now, that doesn't mean it's not necessarily a problem statistically, but at least we've accounted for why it's happening, okay? So we do have some clear evidence of extreme values. Other thing that we can do here that's a little bit new is what I've done is I've gone through and I've ran my basic means table here without means or standard deviation or skew kurtosis and things along those lines, just to get my means and my variance. So what I did here is I just went to analyze descriptives, and then I don't need to save standardized variables, but if I go to options, take off skew kurtosis, and I can click variance instead of standard deviation, min, max. I don't need those, okay? And then if I hit OK, what it's going to do is it's going to give me this table that's got my means and my variances. Now, what I want to do here, remember that we have assumptions in our mixed factors ANOVA. We have homogeneity of variance within and homogeneity of variance between, right? So that we're saying that within each group, we're assuming that our repeated measure should have relatively equal variance across repeated assessments. We're saying for each repeated measure, our different groups should have relatively equal variance, right? So what we need to do is start thinking about sort of how do we go through and capture this. Now, Matt, in SPSS, what's SPSS giving us a test of in terms of homogeneity of variance?
Between subject factor.
It's between subject stuff, right? So what I've done here is I've created a table. Here's vignette 1, 2, 3, 4, group 1, 2, 3. And what I did is I just pasted in variance estimates in this table, right? And what I can do is I can go through and take a look. Remember that we talked about our Fmax statistic. Fmax is calculated as the ratio of your largest variance to your smallest variance. And what we're looking at here, you can get quite a bit of a tolerance. If you've got a nice balanced design with everything nice and normal and things like that, so people would say up to F max of 10, that's a pretty big discrepancy, right? As we start to get unbalanced designs and data that are not normal and things along those lines, one of the things that's a benefit here is all our skew, at least it's all going in the same direction, right? We don't have things going in opposite level skews. It's all sort of pointing in the same direction. So that's giving us some good stuff here. But what I can do is I can go through, and so if I'm looking at my negative group, if I take my highest variance, which is 2.994, and divide it by my smallest variance, which is going to be 1.046, I get an F max of 2.86. Okay. Again, if we're saying somewhere around a cutoff of 3 in terms of being problematic or unbalanced and sort of non-normal stuff, we're still looking okay-ish here with this, right? Same thing if I calculate an F max for across groups for my benevolent group, right? If I take 1.111 and divide it by 0.56, gives me an F max of about 2. If I do that, it's for the same thing for interpersonal. And so here, these are F max statistics that giving me a sense for homogeneity of variance with across repeated assessments that SPSS is not going to give me. Okay. Now, what about homogeneity of variance at across groups at first vignette, second vignette, third vignette, fourth vignette? Matt, do I get these in SPSS? Across groups?
Oh, sorry, yes.
Yep. These are the ones that we're going to go through. This is just our Levine's test, right? Well, it's not, it's an F max, but it's going to be the same type of thing as our Levine's test here. Okay, so we've gone through, and what we can do is just go through and take a look at these F max statistics and see, do I have across these cells problems with potential violations or problematic violations of homogeneity of variance or unequal variance, both within and across, or within and between assessments. And if I had something that was popping up as super big, now here across for vignette 2, we're seeing a ratio that's getting close to 4, right? Suggesting that probably the variability that we're getting in these in vignette 2 is not the same across groups. 2 is our combat vignette, right? So there's potential some stuff in there that I'm going to want to account for. But basically what we're doing with this is saying, hey, can I just start for my follow-up test, start grabbing error terms and stuff from my mixed factors ANOVA? Probably not. There's really nothing in here that says that should be a good idea. Okay. All right. So here is our write-up, okay, that we've kind of condensed down. We're talking about missing data, implausibility, what our total sample is. Here in terms of our distributions, just because everything's kind of looking the same way and it's all a mess, right? Kind of going through and trying to condense this down in an efficient way that doesn't lose important information, that says, hey, here's for our 4 vignettes for negative, benevolent, interpersonal, and just look at those, like they're all bad, right? None of it's good where I'm saying, oh yeah, it's bad for this group, it's okay for this group. Talking about our histograms, talking about our box plots. For this case, because we've got 12 different cells to account for, trying to go through and condense this down a little bit. Now, that's not always going to be the way I want you to do this. If you have questions about it, come talk to me. For the screenings that you have to do, they're more manageable in terms of what to account for. But for this example, we're kind of condensing things down. Here, same thing, we're talking about outliers. Anything that's not 8 is going to end up as an extreme value. So do I want you to list out half the sample in each one of these with this? No, we're kind of noting this. Homogeneity of variance, this is kind of the new thing here. We say some evidence potential of violations of homogeneity across groups. And then what we're talking about here is what we'll get with our Levine's test. We haven't run that yet. But then we say F max for within group variability appears acceptable, right? So relying on my Levine's for between, but looking at F max for my within. Sphericity, we assume that it's violated. So in terms of recommendations, Got missing values, we've got unequal cells, we've got violations of normality and extreme values. We've got violations of homogeneity variance and violations of sphericity. Okay. Are these nice ordered data? No, I've basically violated all my assumptions across all things, right? Does this mean that we're not going to proceed with any type of analyses? No, we're not going to do that, right? But what we want to do is try and go through and account for this and say, what are the potential impacts? How do I need to start thinking about these, right? So we started talking about cases with missing values. Want to know that it's not that many of the full group, but if these were all, let's say, for our negative group, that would be an important thing to know. So I want to go through and say, probably ought to check to see where those negative or where those missing values are coming from, right? Now I know in these data that these are just cases that we didn't have values for. That was just kind of random due to errors and stuff like that. So it's not actually a concern, but something that I would want to check into. Violations of normality observed in friendship ratings, not necessarily problematic, given the size of the cells and the assumption of normality in the sampling distribution. You know, but we do have some extreme values, and I mean, we probably shouldn't just ignore this. One thing we should probably do is maybe think about transforming these, right? It would definitely be worth now. The problem with transforming these data is now all of a sudden, instead of taking something that's nice and interpretable and saying, yeah, the average friendship rating for this vignette was X. Now we've got something with a log transform or a square root transform or an inverse or something like that. And we lose practical meaning. We can still look at associations, but we start to lose interpretive stuff. And so we'd want to be very careful with that, but probably something that we should look at, right? And we say greenhouse guys are corrected in the final model for presumed violations of sphericity, okay? Also recommend tailored conclusions to acknowledge interpretation of transformed as opposed to raw data if we go through and do that. But in terms of screening, there's not anything, the only thing that's really actually new is just that little table I built down there to calculate F max for between and within. But outside of that, it's just the same screen that you've done before. You just kind of having to chop it up into a bunch of parts, so kind of more things to keep track of, okay? Questions about this, concerns on this approach, sort of what we're wanting to do here. Awesome, okay, let's do this. Let's go through, take a break, come back at 3:45. We'll take a 10-minute guy, and we'll jump into quick analysis of these data here. All right, folks. Going to jump back into this and work through. We've already gone through in SPSS sort of what we're going through and asking about in terms of pulling like the pull down menus and stuff like that. So to save a little bit of time, we'll just work from the handout for the omnibus for the beliefs stuff. So here, again, all the same stuff that we went through before in terms of pull down menu, requesting our outcome. In terms of output, once again, we're seeing my repeated measures. Did I go through, and this starts to become important. So in this data set, I've got 8 different vignettes going through. Did I check and grab the right vignettes for this study? Yep, looks like I did. Looking at my 3 groups, do these all match up to what I expect in terms of who should be represented there? Yep. Here's my descriptives table telling me my mean values for each one of my vignettes across each one of my groups, standard deviation there. So making sure that all looks good. If I go down through and then look at my multivariate tests, remember we ignore that. Multis test, ignore that. Going to go straight down into my test of within subjects effects. Okay. Let's see, Josiah, what am I seeing for my test of within subjects effects here?
There is definitely evidence for differences.
Differences in what?
In between, what
Yeah, I'm seeing collapsing across groups, ignoring profile. I have very clear evidence here of differences across my vignette ratings, right? So I know that if I just ignore my grouping factor and just look at the pattern of means, I'm seeing that people are responding differently to these vignettes in terms of friendship ratings relative to across the repeated assessments, okay? What about, Matt, if I go down here and I look like that at my rating by class, what am I seeing here?
Evidence for. Trying to figure out how to phrase this. For differences among the ratings of friendship that depend on whatever class was. I don't know what class was.
Perfect. Yep. Differences in the pattern of rating of difference in the pattern of ratings across these vignettes based on the specific profile. So that between that individual difference factor is changing the pattern of means that we're seeing across these repeated assessments of these vignettes. Now, what's my strength of evidence here, Matt?
Partial data square.
Well, I kind of wrote some stuff up here. I got an S value of 5, a Bayes factor bound at 3.88. Looking at my P value, do I have super strong evidence?
It's unlikely, but it's not super strong enough.
Yeah, it's some, right? So I'm feeling okay, but maybe not through the roof excited about stuff until I get down a little bit farther. Okay. So looks like I have a repeated measures effect for vignettes, so that yes, collapsing across groups, my vignette ratings are different across sort of different trauma scenarios. And it does look like I have evidence that belief profile may impact how people are responding to this successive series of vignettes. Okay, if I go down through ignoring my within subject contrast, because there's nothing useful there. If I drop down to look at my Levine's test, here I'm seeing pretty clear evidence of violations across most of these, right? So the way in which people are, the variability I'm seeing within class differs across each one of these groups, right? And also for all vignettes. So I've got a pretty clear evidence for violations of homogeneity, which we had talked about. But then we've got this test of between subjects effects. What does this mean? What do you think, Basha? Yes. Friendship vignettes across what? Yeah. So differences in belief class across aggregate friendship rating, right? So collapsing across if we're looking at the average friendship rating for members of the negative profile versus the benevolent profile versus the interpersonal profile. If we collapse, sort of take the average rating that they're providing across vignettes, we have evidence of differences across these three belief profiles. Is this meaningful and interesting? Yeah, why is that? Yeah. Emily?
So like the class that you're belonging to will impact.
Now, this is qualified by that interaction, right? So we can't make strong interpretations about sort of this between subjects difference. But what this is saying is that just based on what profile you're in, it starts to change how you're responding to these vignettes, right? Ignoring what vignette we're giving you, we're seeing that there is evidence of some type of difference based on what belief profile that just kind of overgoes and just sort of changes your overall attitude towards providing friendship, which within the context of this. Now, in the other example, collapsing depression scores across repeated assessments didn't give you anything that was interpretable or interesting. Here, it kind of does. Now, it's qualified by that between, by, within interaction, but something worth thinking about. Okay. And so then we go down to our, oh, got another test between subjects effects. Here's our marginal means that we had asked about, right? So here's average rating across vignettes for negative, average rating across vignettes for benevolent and interpersonal. Here we got collapsing across groups, average rating for vignette 1, 2, 3, 4, and then here's our 3x4. These are our marginal means. It's kind of a nice table to go through and take a look just to kind of see patterns, what's going on. Again, when I report, I like to report observed means, but this is a nice kind of quick and easy way to go through and take a look at stuff. And then if we go through and take a look at our plot, what are we seeing here? So blue is our negative, red is our benevolent, and green is our interpersonal. And vignette 1 is going to be car accident, vignette 2, a combat, vignette 3 is sexual assault, and 4 is disaster. What are we seeing in this profile, Allie? What's that? I'm sorry.
I don't know why
Shout.
I cannot pick up my voice. For all three of the groups, it looks like for the combat,
Okay, yeah. Across vignettes, it looks like regardless of where you're at, you're seeing willingness to provide friendship for a potential combat survivor is being rated as lower, right? What else are we seeing? The negative. Yeah, this negative profile, they're consistently showing lower elevation on this, right? And so if we take a look at this, this starts to put into context some of the effects that we found. So we found a main effect of repeated measure, which is very obvious, right? Well, now this is sort of super zoomed in, like the actual differences we're seeing aren't in absolute magnitude all that big, right? But zoomed in, we're saying that, yeah, we have evidence of differences, and those differences kind of look like they're happening right here for that combat. But then we're also seeing that between group differences that we saw. So it looks like, yeah, collapsing across assessment rating or across vignette rating, we've got one profile that's acting differently than the other two. Okay. So the question is, and if we go through and pop up and say, how do we go through and talk about this? For the omnibus effect, we say results of a 3x4 mixed factor ANOVA provide modest evidence of a class by rating interaction. The within by between subjects effects of these data suggest differences in willing to maintain friendship with hypothetical survivors of traumatic and not non-traumatic, different types of traumatic events may depend on pre-existing beliefs about the impact of trauma. Okay, so just kind of summarizing that. Now, here with this interpretation, did I talk about direction or trends or anything that was going on? No, I'm just saying, I don't know. Based on the omnibus test, they're different somewhere. Okay. All right. So the question then is, how do we address this? What do we do about this? And this is where it starts to become important to have a very clear sense and plan for what you want to do and how you're going to execute that. Okay. So for this example, we're going to make believe some stuff. Don't make believe stuff in your own data, but for this one, we'll make believe some stuff. Let's say that if we just look at with this 3x4 design, in this, there are 30 possible pairwise tests that we could take, that we could make, right? We got 6 within for each class. So I've got 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, 6 multiplied by 1, 2 more, right? So I've got 6 within with each class. And then for each vignette, I have 3 possible comparisons. I've got 1 to 2, 1 to 3, 2 to 3, got that 3 times. So total of 30 possible pairwise comparisons that we could pull from these data. Okay. Now, The actual number of all possibles is actually a lot bigger. These are the 30 interpretable ones that we can make. Obviously, we're not going to compare, it wouldn't make sense to compare negative MVA to benevolent sexual assault. That doesn't make any sense to compare those. But in terms of interpretable comparisons, we're at 30. Okay. Do we want to run all 30? Does anybody want to talk about all 30? Does anyone want to interpret all 30? Absolutely not. So we have to have some sort of strategy plan for how we're going to tackle this. There's not one way to do this. The way you tackle this is going to depend on your hypotheses, your research questions, things along those lines. So these aren't the types of analyses like this is the right way to do it, because there are any number of ways you can go about doing this. What you want to do is have a strong rationale for what you're going to go through and do. So we're going to say for this, that before we ever got started, what we were interested in is our hypotheses were that people would be less willing to provide support for combat survivors relative to the combination of MBA, assault, and disasters. Okay, that was our hypothesis. We say, regardless, my belief is that there's something about combat trauma, about stigma, that people are just less willing to provide friendship for these folks than other groups, right? There's something special about it. And so what I'm going to do then is I'm going to a priori, I'm going to look at the contrast within subject contrast of combat versus the combination of accident, assault, and disaster across each one of these. And because I've a priori said that, hey, this is why I'm doing this whole thing, I'm going to run each one of those at per comparison error rates. So, okay, so just 0.05s. People understand what we're going to do there. So I'm going to run a linear contrast, so within subjects linear contrast, repeated measure contrast, comparing this, compared to these two, this, to these two, this, or these three, okay? A nice simple way that sort of captures my predictions. But looking at this, what other questions might we have? Something that may have occurred to me after I eyeballed the graph here. What do you think, Rachel? What would you be interested in knowing? Yeah, does this negative, because it looks like this negative class is kind of different than the other two folks, right? Now, maybe I predicted that before, maybe after I looked at it, right? But maybe what I want to do is I'm like, oh, there, I'm seeing daylight here, right? Is this negative class different than the combination of the other two? Other two look pretty similar for the most part, right? So what I'm going to do then is in an exploratory analysis, what I'm going to do is I'm going to take a look and ask whether or not the negative group is showing lower ratings than the combination of benevolent and personable, benevolent and interpersonal for each vignette. Okay, so here what I've got is I've got so how many tests is that, Rachel? If that's my contrast. 4. Okay, but because this was post hoc, how many tests did I run in my head? Here would argue that I ran 12, right? What I did is I looked at negative versus benevolent and impersonal, negative, benevolent, and impersonal, this one, this. And so I actually ran 12 in my head and then just decided that I was only interested in 4. If we're being honest, what we need to do is probably figure out some way to go through and correct for all 12 of those comparisons, because it wasn't just like, oh, hey, these are the ones I wanted. That was after I put together all possible comparisons and then did something, right? So because I've got a total of 12 pairwise tests, what I'm going to do is I'm going to say, I'm going to try and get something that corrects for something in that vicinity, okay? So what I'm going to do with this is I'm going to run a modified Tukey, okay? And modified Tukey, remember, is we can harness that Tukey Q and use that to try to sort of get something that's around the same area. Do I want a Bonferroni correct for that? No. God, no, right? That's, I mean, Bonferroni correct for 12. One, Bonferroni is not a post hoc test. And then two, it's going to make it impossible to identify anything with that, right? Can I ask SPSS to give me a correction for 12? No, it's just going to correct for all possible things. That's no good. So what I'm going to do for these analyses is I'm going to say, can I get close with the Tukey? Okay. Now remember with a Tukey, and you've got that handout that I sent around our Q table. Remember that with Tukey, what I do is I need to take the number of steps between my ordered means. That's the number of means I have in my sample, and then look at my error degrees of freedom to find a critical Q. And then I go through and I calculate a Q test, compare against my Q critical to see if I have evidence for my effect. Okay. Now, the nice thing is that Q, remember, has a direct relationship with T. Okay. T is just my T test is equal to Q over the square root of, what is it, over 2. So what I can do is I can start moving back and forth if I want to kind of hijack Tukey. What I can do is decide how many comparisons I want to account for. I can find a critical Q, and then I can take that critical Q, translate it into a T critical, and then just start running T tests, whatever I want to do, or whatever contrast I want to do, and compare those each against that critical Q. Okay. So if I go through and I take a look and I say, okay, if I say 5, what if I set R equal to 5? R equals to 5. Remember that this is N, or what? R minus 1 over 2. Okay. So if I have 5 times 4 over 2 gives me a correction for 10 tests, right? How many do I want to correct for? 12. If I set R equal to 5, I'm short. I'm actually not correcting for all the tests that I want to, okay? I could set R equal to 6. R equal to 6 is going to give me 15 comparisons, right? 6 times 5 divided by 2 is 15. That's too much. But I don't know. This is all exploratory. This is all just me kind of going through. So maybe I'm comfortable, and this is what I'm going to do. I'm going to say I'm going to just be conservative, and I'm going to go ahead and I'm going to account for 15 comparisons, because there was some other comparisons that we made previously and things along those lines. Okay. So I'm going to set R equal to 6. And then what I'm going to do is I'm going to go through, because what I need to do in my Tukey table, I need to find a degree of freedom. And remember, with my Tukey, my degree of freedom is going to be the degree of freedom between tests. But I've got unequal samples, right? So what I'm going to do is, because I'm taking a conservative approach, if I go and take a look at the smallest degrees of freedom between the smallest comparison that I'm going to make, right? My negative group has 44 people. My interpersonal has 45. So if I take 44 plus 85, subtract 2, because that's my degrees of freedom, I get degrees of freedom of 127. Now that's going to underestimate if I compare interpersonal and benevolent, but I'm still going to be conservative. Lower degrees of freedom is going to be a more conservative test. This is all jazz. This is just like me kind of like making things up to try and get something in the vicinity of what we want to do here. But what I'm doing, if I had to stand up in front of a room and defend this, I would say I'm taking a conservative approach. I'm correcting for more tests than I'm actually running. I'm sort of using degrees of freedom for the lowest number of people in the comparisons that I'm going to make. And so this is how I'm going to go about things. Okay. Questions on kind of my thinking with this? Okay. So if I do that, if I go through, and you won't find this in the table because it's a weird degree of freedom, but if I go on an online calculator and I ask for my Q critical with R equal to 6 and 127 degrees of freedom, I get a Q critical of 4.10. That would say that any comparison that I run with Tukey would need to have a Q test Q of 4.10. But what I can do, test Q is a pain in my ass because it's a whole bunch of stuff. What I can do is I can take that critical value, I can turn it into a T, and what that gives me is a critical T of 2.9. Okay. Now, if I go through, see if I can. Look at a critical T value for 127 degrees of freedom. Is that right? No, I don't want a one-tailed. That's not useful. Okay. Different level. .05. Okay. So comparing, so if I were to just run a t-test with 127 degrees of freedom, my critical value would be 1.97. Okay. But with my two-key, correcting for 12 comparisons, my T critical now, when I change that 2key Q over to a T value, it's 2.9. Does this make sense, Amanda? Yeah, why is that? Yep, I set my goalposts farther out, right? Because what I'm trying to do is address increased type 1 error for running multiple tests. And so what happens now, in order to claim evidence for my effect, my benchmark gets farther out by actually quite a bit, by almost a full point, right? 1.97 to 2.9. I'm getting a pretty stiff penalty for not having any predictions on this in the first place, right? So, but once I've gone through and I've done that, what I can then now do is say, okay, I've got a critical value that I can go through and test against. And if I find a test statistic that exceeds 2.9, I can claim evidence for this with correction for two-key, with correcting for 12 comparisons and things along those lines, okay? People kind of understand how we're kind of worked through sort of this strategy. Okay. So what we're going to do is we're going to go down through and do this. So first thing I want to do is, if I go to my output, not quite yet. Okay, first thing I want to do is I want to run my a priori contrasts, right? These are my within subjects contrasts. This is where I'm saying, you know what? I predicted ahead of time that across each one of these belief profiles, folks will rate less willingness to maintain friendship with combat survivor work versus the combination of the other three vignettes. So what I'm going to do is I'm going to go through, because I have predictions within each one of these individually. I am going to open up my data set, sort this to pull my split file off. I'm going to go to data, split file. I guess I'm going to turn it back on. Okay. I'm going to go to my split by class. And then what I'm going to do is I'm going to go to analyze, general linear model, repeated measures. And I'm going to call this vignette I have 4 levels to my vignette. Define this. I would say friendship, combat, assault, and disaster. And then I'm going to go think my request here. Yeah. And then I'm just going to ask for my descriptives here. Hit continue and paste. So someone tell me what this is going to do when I run it. What's my split file going to do? Emily? Yep, going to look at each one of my classes, and then within each class, what analyses am I requesting? Well, I'm going to get there. I'm just going to run a one-way repeated measures ANOVA at each level of my grouping variable. And if I do this, what I'm going to get is here. And that. Oh, it's trying to run it on the wrong data set. Oh. There we go. Okay. So what I've done is I've run a oh, here, let's do this. Go to data. Not that. This gets us there, it just does it a little bit. So it breaks things up a little bit. If I go to split file and organize by output, this will make what we've done a little bit clearer. Okay, there we go. So we've got a within subjects ANOVA for my negative group. Okay. My benevolent group. Okay. And my interpersonal group. And if I go through and I take a look, and this isn't why I'm doing this, but if I was curious, I would see that, yeah, I have evidence for differences across vignette ratings for my negative group. Here, I have evidence for differences in my benevolent group. Oops. Benevolent group here, and evidence for maybe not differences in my interpersonal group. It's kind of weak here, okay? But this isn't why I'm doing this. What I know is that I have differences in my repeated pattern of repeated measures across my different groups. And so what I'm going to do is I'm going to go through and I'm just going to go through and look at each one of these and start cranking out my plan contrast. Okay. So we're going to start here with my negative group. So what I've done is I've requested just a one-way ANOVA or one-way repeated measures ANOVA looking at just my negative group, okay? And remember that from our lecture, what we've got is we've got our formula to conduct our within subjects contrast, okay? And so what are my weights going to be for this contrast? What do you think, Matt?
We're comparing,
You got four vignettes, and we're comparing combat versus the combination of the other three.
all right, so combat would be 1. The other 3 would be -1/3.
Okay, who do I expect the lower ratings for?
I'm sorry, for combat.
The combat. So we got -1 times 1. Well, actually, the way this is set up in the data, it's gonna be 1/3, -1, 1/3, 1/3. Okay. And so what I can do is start working through and using the means and standard deviation stuff put available in this output, I can start calculating the statistics that are of interest to me. Okay. So here I've got my contrast. I've got 1/3 times 7.48 for MVA, 7.39 for assault, 7.39 for disaster. Okay. -1 times 6.73. This is my combat, right? Run this out, I get a value of 0.69. Okay. Josiah, what does that 0.69 tell me? How do I interpret that? What does the value of that contrast mean? Amanda?
Means that the ASA disaster are 0.69 higher.
It's just an average difference of those, right? Because we've specified a standard set where the sum of our absolute values of our weights sum to 2, right? We know that we can go through and just to interpret this on the same scale. And so what we're seeing is that on average, for individuals in the negative group, they're rating combat as 0.69, about a little over a half a point, between a half and 3/4 of a point lower than the combination of the other 3. Okay. If we then go through, take that, drop that into my formula for my contrast, I've got 1/3 squared plus 1/3 squared plus 1/3 squared plus 1 squared times, here we need a mean squared error. And this is where we're going to go. This is why we ran the repeated measures ANOVA the one way, is because what we're going to do is we're going to take that error rating, the mean squared error, from that one-way repeated measures ANOVA. Okay, that's my error term for my contrast. So I go through for the one-way, and this is just looking at the 44 people in my negative group. I'm going to pull this, drop that in there, divide it by the number of people in my sample, which is 44, which gives me a test and a p-value. Okay, I can calculate an S and a Bayes factor. I can go through and I can take my point estimate for my value of my contrast, plus or minus my standard error that I calculated here, multiply that by my 95% confidence bound interval for this with, so for T with 42 degrees of freedom, my critical T is 1.99, right? So I go through and calculate that, gives me a confidence bound of 0.25 to 1.13. Okay. Brittany, can you give me an interpretation of that confidence bound? Or
I was about to say, I can't see.
okay, sorry, Amanda. You became Brittany for a moment.
It's the Todd eye.
Yeah, it was. It threw me off base. Yeah. Can you give me a interpretation of that confidence bound? Yep.
Like it's saying that disposable, that like any of the content population.
Yeah, exactly. I would take a look at this and say data supported values for the true difference in vignette ratings for combat versus the combination of assault and disaster, anywhere from about a quarter of a point to a little over a full point difference on this scale. Okay, so my best guess is about 0.69, right? But my data would support any, if you told me any of those values in that range, I would say, okay, that's sort of would be acceptable, right? What I can then do is drop down and I can go through and calculate an effect size here. What I've done is I'm just taking the pooled variance of all my ratings in the sample or involved in the contrast. So I've taken, to get my pooled variance, I've taken standard deviation for MVA, squared that, plus standard deviation for combat, squared that, standard deviation for assault, squared that, standard deviation for disaster, squared that, divided it by 4. Why can I do this? Yeah, I got equal, it's within stuff. So it's the same thing, right? So I can take the average of my variances, go through, take an average standard deviation, take my point estimate for the value of my contrast, divide it by my standard deviation, and I get an effect size of 0.54. Elizabeth, that's your name. Can you give me an interpretation of this effect size?
I believe it's
Eh, medium. Yeah, 0.5 is medium. But what would be a practical interpretation I would provide there?
there is a smaller difference in it was the negative group,
Hmm?
or it was lower compared to your well,
Okay.
I'm pulling it, I'm working with it.
Can someone help her out a little bit with interpretation of the effect? Yeah, Amanda. Yeah, right. So within this, we're seeing that for individuals in the negative group, these folks are scoring, and so we can sort of turn it around however we want, right? Probably I would think about these folks are scoring willingness to maintain friendship with a hypothetical combat survivor about a half a standard deviation lower than the combination of car accident, sexual assault, and disaster, right? So together, this is a lot of hand calculation because SPSS won't do it for you. But this gives us a lot of information about what's going on here, right? And so what I can then do is I can run the same calculations for my benevolent class, right? I can go through, calculate my the same contrast, get the value of my contrast, calculate my test statistic and my p-value, S Bayes factor, calculate my confidence bounds, calculate a confidence interval, all pulling with my contrast pulling from my mean squared error from the one-way ANOVA or one-way repeated measures ANOVA just within my benevolent class. Okay, and then I can do the same thing for my interpersonal class, right? And so to go through and pull this together. And so if I go through and I run these same statistics, I can kind of go through and put together a little table here that's saying, here's the actual observed difference between my combat rating versus everybody else. Here's my p-value, and here's my effect size, okay? So thinking back to this, Robert, we had an interaction. We had a between by within interaction. What did that between by within interaction tell us?
There was evidence for an interaction between class, so for the beliefs, belief about trauma and the
And so saying that the pattern of beliefs, pattern of ratings we're seeing across these vignettes differs based on what profile people are in, right? If I'm looking at here, this kind of informs that for me. Again, there are any number of ways you could go through and start to qualify this. But for me, I'm saying, boy, for this negative profile, I'm seeing my effect size here is about at least twice or a third again over what we're seeing across these other two profiles. These other two profiles we're seeing about, I don't know, a little under a quarter of a standard deviation to about a little under a third of a standard deviation. Here, over a half standard deviation. We're seeing a bigger discrepancy specifically for this negative profile than we are for the other two, which is, again, a nice way to quantify what we're seeing here, okay? So next thing we're going to do, so that takes care of our contrasts, right? Our a priori stuff. Other thing too is I have these comparisons where I want to go through and I want to look at exploratory, say, I want to take a look to see whether I have evidence for the negative group scoring lower on friendship ratings than the combination of my other two profiles across each one of these vignettes. Okay. So this ends up being pretty easy and straightforward to do in SPSS, particularly now that it will calculate effect sizes and confidence bounds and all this stuff for you. What we're going to do is we're going to request between group contrasts for each one of our outcomes. So here we're just running a one-way ANOVA, right? And for our outcomes, we're going to have friendship or ratings for MVA, combat, sexual assault, and disaster, and just look at these by class, right? Here we've got our contrast, negative 1.5.5. That's comparing my negative group to my other two groups, right? And then I'm just asking for confidence bounds and effect sizes and things along those lines, right? So if I go through and I run this in SPSS, it gives me my table. So again, just all we're doing. Yeah. Go through with this. All I'm doing here is going to compare means, one-way ANOVA. I want to look at friendship versus MBA, combat, assault, disaster by class, estimate effect sizes, go to my contrasts, set up my contrasts here as I would, as you did before with your one-way ANOVA, and then go through and run it. And what you're going to end up with is a set of means, right? So you can go through and take a look at this as just your observed means. Homogeneity of variance tests. So we're going to go through and take a look, and it looks like across each one of these vignettes, we have evidence for violations of homogeneity of variance. So we're going to use that to inform which line of the contrast we go through and take a look at. We're going to go down through, here's our one-way ANOVAs. Do we care about our one-way ANOVAs? Not really, right? The only reason I asked for a one-way ANOVA so is that I could get SPSS to build me a contrast. So I don't care about that. That's not relevant. I already did my stuff in my interaction. This is something I need to be concerned with. But what I can do now is go down through and take a look at my contrasts here, okay? So this is my contrast effects. I got the value of my contrast, my test statistic, my p-values, and then confidence bounds around my around the value of my contrast here. Okay, and so of these, which one's the only one that's kind of popping up? Yeah, the big one, right? The one that looked the biggest in there, right? So for my combat survivors, and again, we're not assuming equal variance because we saw evidence for violation. If I go through and take a look, I'm like, oh yeah, I got a pretty small p-value here, looking like there's about a 3/4 of a point difference in ratings of friendship for hypothetical combat survivor across my negative group versus the combination of my benevolent and interpersonal group. Okay, nothing else comes up. Remember that here we're testing this against a T critical of 2.9. Okay, now what happens if I go through and take a look at this versus my critical value? Do I get to claim evidence for this? No, I don't, right? This is a pretty small p-value, but remember that I corrected for 12 tests because this was all exploratory and me just cherry picking stuff. And so I got penalized pretty heavily for that. And if I go through and I compare against my critical value that I set, I might look at that and get pretty excited. But if I go through and I take a look, I might, what I literally did is cherry pick the biggest difference I could find in that whole design, right? So are these different? Maybe. Can I claim evidence given the correction in the benchmarks I set up? Probably not at this time, right? If I go down and take a look in SPSS, and again, we used to have to do all this in, as of last year and before, you have to do all this by hand. SPSS gives it tell you that's kind of nice. We're seeing an effect size of 0.64, which is promising, right? But again, given the benchmarks and sort of the conservative approach we took here, we are probably limited in what we can interpret based on this. Questions about the approach? Show of hands if someone thought this was a lot. This is a ton. These designs, and I wish there was a way I could say, oh, do this, follow these steps, and you'll get the right answer every time. That's just not how these work, okay? What you got to do is think about, here's the thing, here's my approach. The omnibus stuff, easy peasy. Once you get after that and have to figure out how do I go through and deconstruct within subjects effects, between subjects effects, all that stuff, you got to have a plan in mind. You got to think about what am I doing? What's the purpose of these tests? And then proceed forward with that. Okay. Yeah.
I have a question, so I remember last semester when we did like with the 1/3, we had to do that SPSS between certain stuff.
Yeah.
I think it's the 2000.
Oh, you know what? Oh, yeah. If you go, yeah, only 0.33 will get you there, right? But what I can do is I could set, if I want 1, 1/3, 1/3, 1/3, I could set my contrast value to 3, -1, -1, -1. That'll give me correct. Can I interpret the value of my contrast? Can I interpret the confidence bound around that? No, I mean, it doesn't mean anything. But my p-value and my test are perfect, right? Is my effect size calculated in SPSS correct with that? I use 3, -1, -1, -1. Nope, that's going to be all of them. Just the p-value, and the test statistics, those are true. And I can go through and take a look at that. But I'm going to have probably calculate the value by contrast, confidence bound around that. But if I go up and through and take a look, this is easy because my t-value is correct. My standard error, I just pull it through. I've got a correct standard error. So calculating the confidence bound is easy because everything I need is there available for me in the output. Good question. All right, cool. Let's quickly jump into this other comparison. Oh, yikes. My ordered beliefs. This gets a little bit easier, okay? So we've gone through, we've run our omnibus tests, right? And we're saying, okay, this is kind of what we've got. So across all three of these treatment groups, we're seeing reductions in BDI score over the course of intervention. But how am I going to go through, what approach do I want to take to go through to kind of tease this apart? Well, there's a couple of things I could do. One, what I want to do is just say, when we're going to treat this all as exploratory, right? I just saw this. I'm just kind of wondering, these are new. I'm doing some programming at this inpatient unit, and I'm just wanting to see kind of what's going on with these different outcomes. So we go through, it's all exploratory. So what I'm going to say is, okay, I've got evidence that yes, changes in depression differ over time, differ across these different groups, okay? But given this output, Natalie, what are, in terms of within subjects effects, if we're thinking about across each one of these programs, what are the within subjects effects or the within subjects comparisons that are probably the most interest to me? From a treatment standpoint. Anybody? Yeah.
Intake to 6 weeks.
Probably intake to 6 weeks, right? Do I care whether or not they have an evidence of a clear difference between 2 weeks and 3 weeks, or 3 weeks and 1 week, or 2 weeks and 4 weeks? No, right? I mean, could I run those? Sure. Are they interpretable? Sure. But are they informative? No, right? And for this, for these analyses, do I have any concerns or any question about whether or not that's going to be some evidence of a non? No, it's going to be massive, right? So, but what I can do is I can focus on using SPSS and its ability to go through and run comparisons for me, to go through and actually just run the effect sizes and the confidence bounds that I'm probably more interested in, right? So I've got 3 tests that I'm going to run across each one of my groups. I'm going to look at pre to post. And if I'm just looking at pre to post, what test can I use to just look at that? What's that? Yeah, just what kind? What's that? Yep, 3 paired t-tests, right? Okay. Then I might also want to take a look at, see what I've got, if I have any evidence for differences across my groups. Where might I be interested in looking at between subjects differences here? Again, I'll eyeball clinical folks because this is kind of a more clinical question. What do you think, Robert? Intake, yeah. And why might I be interested in whether or not I'm seeing differences in intake?
That is the level of.
Yeah, right. Should I hope to find differences in intake? Hopefully not. Hopefully different. Like, hopefully the reason I'm getting an interaction of program by time isn't because people started in different places. That would be kind of a bummer, right? So yeah, I want to go through and take a look, but I'm probably going to be more interested in whether or not, hoping that nothing comes up actually, right? Where else might I be interested in taking a look at whether or not I'm seeing differences? I think, Rachel. What's that?
The last session.
The last session down at the end. What do we got? 6 weeks, right? And if I'm looking at this, it looks like there might be something. It looks like program 3 is quite a bit small, lower there, right? And so, am I seeing differences here? Now, I cannot emphasize enough that there are better and more interesting ways to analyze these types of data. This isn't the type of analysis you would want to use for that. There's other stuff that we can look at, actual growth trajectories that are more interesting, but we certainly can do this, right? So we found an interaction of program by assessment, suggesting that reductions in depression over time are different for these different programs. And so probably the question we want to say is, which one of these is most effective? Which one of these are we seeing sort of the greatest amount of reductions, right? Now, there are a whole lot of other comparisons that we could make, but for me, pre-post across each one of these groups, right? And then within, at pre and post. So Robert, how many comparisons, pairwise comparisons can I make at pre or at baseline? 3. And how many at final session?
3.
Right? So I've got 6 between. So I've still got 9 comparisons that I'm going to make. Now, these first ones, these first 3, I don't need to correct. I know, I just look at this and those within subjects effects, for particularly for with sample sizes of whatever we've got, those, the test is superfluous, but what we're wanting to look at is effect sizes and sort of just generally trying to think about how do we go through and manage these, okay? So what we could do is we could go back through and run this modified Tukey that we did before, or what's another thing that we talked about last time that was kind of helpful for organizing this stuff? Anybody remember? Yeah. Yeah, the Benjamin Hochberg, okay? So we'll say for these analyses, I'm going to say that the first 3 within subjects tests are superfluous because like I don't need to, I can look at that and know that those are going to be different, right? So I'm not going to worry about correcting for those, but I do have 6 exploratory between subjects effects here and here that I do want to correct for. I could go through and run a modified Tukey, which would actually be fine. I could do that, but I could also just run a Benjamin Hochberg and sort of order these up. Okay. So what I'm going to do here is I'm going to go through and split file and just run a paired sample t-test pre-post for program 1, 2, 3. So again, if we just go through split file and run a paired sample t-test, it's going to give me a paired sample t for program 1, where I'm going to get a, and I'm not even interested in that p-value because I already know it's going to be huge. Well, what I can do is I can go through and look at the confidence bound. I'm not running these paired sample t's for the p-value. I'm running them so that SPSS gives me the average reduction in scores and the confidence bounds around that. And then in new version of SPSS, it gives me my effect size here, right? So I've got that for program 1, another one for program 2. Here, my average reduction is now 19 points with data supported values ranging from 16 to 21 point reductions. Effect size here of 1.6. And then for program 3, right? Here, a 20-point reduction, data supported lower and upper bounds of 18.2 and 22.6 with a point estimate of my effect size of 2, right? Basically, this is saying for program 3, I've got a 2 standard deviation reduction in depression scores from baseline to final session. Who's excited about a treatment effect of 2? Everybody should have their hands in the air. That was a pretty powerful effect if we get that much of a reduction. Okay, so we've gone through, and again, less interested in the p-value, more interested in getting that confidence bound and the effect size. And then what we can do if we want to help, this is taking those ESCI plots, right? And here I'm plotting out confidence bounds and point estimates of my effect sizes. What are we seeing here in this output? What do you think, Emily? If this is program 1, 2, and 3. Yeah, just looking at the point estimates and the bars here. What's that? Yeah, it looks like they're kind of stepped. Which program looks like it's performing the best? Yeah, program 3's, at least compared to program 1, right? We've clearly got a larger point estimate of the average change. We've got larger point estimate of the effect size, right? Program 2 is kind of in between there somewhere, right? But in terms of always thinking about our interaction is saying that we're seeing a different reduction in depression across based on these different programs. Here it's looking like probably what's going on is that program 3 is at least outperforming program 1. Okay. So that's our within subjects stuff, but we also decided that we were interested in looking at between subjects things, right? So what I can do here is just set up a bunch of t-tests, okay? What I'm gonna do is I'm just gonna run a t-test comparing program 1 versus program 2, program 1 versus program 3, and program 2 versus program 3, and just look at those t-tests at baseline and at final treatment, right? And if I go through and I do that, I just get here, this is my comparison of 1 versus 2 at intake and baseline, okay? And here I get my p-values for, and we also want to think about equal variance is not assumed. So here we're good with these comparisons. So we've got, looks like some evidence for possible differences at intake across 1 versus 2, and nothing that looks different at 6 weeks for 1 versus 2. And then corresponding effect sizes. Here we've got 1 versus 3. No evidence of differences at intake. And then some evidence for differences in scores at 6 weeks, okay? And corresponding effect sizes. And then here's our last 2 versus 3 at intake and final. No evidence really of differences at the start, but maybe some evidence of differences at the end and corresponding effect sizes, okay? And here's where we go through and drop in our Benjamini-Hochberg, okay? What we've done is I've sort of pasted this into Excel and kind of flipped things around here. But remember what we've got is we've got our tests that we're going to go through and order up based on the t-value, the p-value. They should be sort of close. Probably want to go with p-value because depending on if there's differences in sample size and things like that. So if we order the 6 tests that we ran from largest p-value to smallest p-value, and then calculate our Benjamini-Hochberg correction, what we can do is we can go through and say, here at our 3 index, we've got at 6 weeks, we've got 2 versus 3. Our p-value is 0.018, but our Benjamini-Hochberg comparison was 0.025. And so we have evidence with our Benjamini-Hochberg for evidence that we can say, yeah, based on the data that we've got evidence for a potential difference between 2 versus 3 at that final assessment point, saying that program 3 is outperforming or has lower scores than program 2 with our corresponding S, Bayes factor, difference in across scores, confidence bound around that, and then our effect size, okay? Index test 2 is here, 1 versus 2 at intake, okay? But if we go through and take a look at the correction, even though this is 0.018, not below our Benjamini-Hochberg, so we can't count that one, right? So we skip down, then we say at 6 weeks, 1 versus 3, we have evidence for that with our S, Bayes factor, our value of our contrast, confidence bound around that, our effect size, confidence bound around that. Okay? So basically my exploratory analysis is saying that what I've done here is clear evidence of reductions from pre to post treatment across all programs. I mean, just they're all working. Looks like maybe program 3 might be working a little bit, be a little bit more powerful than programs 1 and 2. But so that's kind of some open question, but that's based on effect sizes and sort of just overall mean reduction. Now, based on this, it doesn't look like we have clear evidence for differences between programs at baseline. But at final treatment, it looks like we do have evidence for program 3 showing smaller, lower scores by about 3 points, about a third of a standard deviation less than where we're seeing these other 2. Now, if we're talking about BDI, is 3 points a meaningful difference on the BDI? Again, people who work with the BDI. Allie, if you saw your client came in 3 points lower on the BDI than they did last week, would you throw up your hands and say, victory, you're cured? You would, that's because Allie's very confident in her clinical skills. Allie I would maybe sort of be hesitant to do that, right? So in thinking about, yes, we have some evidence for differences, right? But what does this all mean? And so this is when we're going through and taking a look at our outcomes, right? Here, just a general write-up. This is a lot, right? But we've done a lot of work to go through and try and figure out what exactly is going on with these, okay? So here we're talking about some within subjects effects, talking about between subjects effects that we went through, some exploratory, and then overall what's going on. Remember, this is kind of the kicker from last semester. You can tell me, yeah, and identify, hey, I found a difference here, this was different than that, or so on and so forth. But we're doing this for a reason, right? The whole purpose of analysis is to pull this together and say something. What can we say about this, right? For our depression example, we say overall results, preliminary support for differences in effectiveness across 6-week inpatient care. Within subjects effects indicated potential for greatest reductions in depression in patients in program 3 and maybe 2 as compared to 1. Between group contrasts also consistent with incremental benefit of program 3. Results provide greatest support for enhanced treatment response in 3 as compared to 1, with promising less compelling evidence for increased efficacy in program 2. Just kind of going through and saying, what did we find? Okay, this is the big thing with these types of designs. They're big. There's a lot of different things going on, wanting to pull it all together. If we drop down into our vignette, right, same thing. We've got a within, got a between that we've kind of set up as exploratory. Here we're saying that results suggest that beliefs about consequences of exposure influence willingness to maintain friendship with hypothetical survivors, whereas individuals in all profiles have reductions in support ratings for hypothetical combat versus non-combat trauma. Effects particularly pronounced in responding to holding negative pejorative beliefs about the consequences of exposure, right? So we all saw all the contrasts came up as positive, but they were particularly large for the negative group. Similar data failed to provide evidence for differences in support ratings across negative and combination of benevolent and interpersonal file, except for combat survivors. Now, with the approach that we took, that actually didn't kind of hit requirement, but we would modify that here. Whereas the omnibus test from the overall mixed factors ANOVA indicated lower supports among participants in the negative profile, the impact of willingness to believe, impact of beliefs on willingness to maintain friendship may have the greatest effects for survivors of military trauma. Just kind of trying to pull all this stuff together. Okay. So one last thing. We've gone through and we found main effects for, in both of these, we found main effects for a repeated measure, which if you've got any reasonable size cells, you probably will, right? Just because it's such a powerful effect. But we then went through and found an interaction. Do I need to spend much time with that main effect of repeated measure in the presence of a between by within interaction? Nope. I mean, maybe note it, but in terms of your write-up, unless there's a reason that you really think that it's important to talk about that, really what we're looking at is that interaction and kind of tease that apart, right? Because that repeated measure effect is conditioned on the between subjects thing. If you ask me, hey, how does repeated measures on this change over time in the presence of an interaction, I can't tell you a straight answer to that. I can say, well, on average, across everybody in the sample, this is what happened. But really, if we want to get a good idea, we have to take a look at different group membership, because that group membership is what's moderating the changes in means that we're seeing across repeated assessments. Okay. All right. That's it for repeated measures ANOVA. Questions? They will come up. I am certain of it, but that's fine. I'm here for you. Touch base. Let me know what questions that you have. Again, you got yourself working together in groups, and obviously confer with other groups. Again, I can't say enough how impressed I was with sort of the approach you all took with this first problem set in terms of going through developing your interpretations. You get to do this in groups, so you can sort of obviously cross against groups, but when you go through and sort of start working on your own stuff, do that. But obviously, if you're running into snags, let me know, and we'll get you on the right track so that you don't wander out in the desert for too long. Okay. Awesome, folks. All right, thank you so much. Have a good night.